Hi and welcome to this new lesson about streaming processing patterns. I hope that here you will be able to take or learn some shortcuts that you will implement later in your work for your streaming pipelines in order to, as you know, not reinvent the wheel because patterns are there to avoid this reinvention overhead. And that's typically the key introductory sentence I wanted to give you here. So if there are some established solutions, there is nothing wrong in using them. On the contrary, you should use them because they are established, tested, and also they are well documented. And it's also it's true for example, design patterns in software engineering, and it's also true for patterns in streaming processing. So let's see now different patterns you can apply for your streaming pipelines. And the first of them is the dead letter Q, and it answers the questions or how to deal with poison pill events. So a poison pill event, just to define it, is a kind of message that your code cannot process, and each time this message flows into your processing job, the job fails, is a critical failure, everything stops. And the letter Q is a pattern that you can implement to avoid this fatal error. And the idea is rather straightforward. So here we have our data processing job and we have two data sinks, our main sink and the dead letter Q sink. And now where our record cannot be processed or cannot be delivered to the dead letter Q, to avoid breaking the pipeline, because streaming pipelines are supposed to be long-running applications, we write this record to the dead letter Q so that it can be analyzed or eventually reinjected again to the main data store. So use it when you cannot parse or process an event. Here I gave you the example of data address storage, but obviously it can also be a streaming broker or message queue for data in motion, anything you want. And there are also two key parts. So the first two are important, but the two last are really, really important. The first one is monitoring. So you need to monitor, and if you can also alert yourself on that queue, on that letter Q, to know the volume of data that cannot be processed, because if suddenly it increases by 10x, it means that something is really, really wrong with your pipeline or with your producers. So it gives you an extra knowledge on that. And also the final part is that dead letter events are still values, are still data that can be a value for you, for your company. And typically, if you don't want to lose them, if you do want to use them in your business pipelines, you will need a way to ingest it again to either your target sinks or to your data processing layer, maybe after fixing some issues meantime. So the next pattern is called content enricher, and here the idea is to add some extra information to the data we are processing. So it's typically the case we have described in the previous module with the data enrichment lesson. Let's take an example. So we have our streaming processing job, and we also have a reference master dataset, which is our relational database here. And the idea is to combine these two parts, so some static and some dynamic part, to enrich the event, to make each to give much more information and simplify also the downstream consuming, because here we already combine the raw data event with some extra information, well, the downstream customers can simply take this data and make some other aggregations or processing on top of it, and they don't need to join the reference table each time. So here the goal is to add the extra information, of course, and this extra information can come from an external storage, aka reference data table, or it can also be a rule hard-coded in the data processing job package, but of course it's less flexible because each time you will need to redeploy your job. The third pattern is the envelope wrapper, and here the idea is to decorate the event. So here too you saw this pattern in action in the previous module in the lesson about metadata, because remember we added there a metadata structure inside our inside our event. So we divided event into data and metadata parts and send it to our Kafka topic. So here the idea is exactly the same as in this metadata lesson. We can add some extra information, like for example, we can add the data processing context, whether the data comes from backfilling or from real time, or maybe what was the job version that generated given row. And the consumers can rely on this metadata to distinguish, to classify the data much better, because a consumer may consider data coming from backfilling, from reprocessing, as not necessarily required for writing, and that's completely fine. It's always up to the business units to define the rules. And here with this envelope wrapper, we can add this extra context much more easier. The next patterns is more on the production side. So here it's called invalid message channel, and we can ask the question what to do when the user cannot process an event. So by user I mean the consumer of the application. So here we have our data processing job that is running, but somehow it cannot succeed in processing each event, and the retries doesn't help. It's the delivery time outed, and the producer writes this invalid record to some dead letter queue on its own. So remember, for the previous approach, the delivery was the dead letter queue delivery was on that side. Here is the responsibility of the data source. So for example, it's maybe the most often you will find this approach in message queues when there is some acknowledged delay, and if during this delay the data processing doesn't acknowledge the record and it doesn't do it in a certain number of times, like for example here we had 3 retries, then the data source considers this record as not processable and writes it to the letter queue on its own. Of course, we could also do it on the data processing side. It's nothing wrong with that, but there are maybe some cases where this dead lettering on the data processing will not be possible, or maybe you will miss some of possible failures, and if you do and don't have this invalid message channel, your job may get stuck and blocked. The next pattern is the dispatcher. So that's also something you saw before, I think in the homework, and the idea is to distribute data correctly to some rules. And here we can imagine that we are receiving data to a single topic. Well, it's not always a good idea to mix different types of data in the same storage. Very often it's a really bad idea because it makes the reading process much more harder to do, and obviously if one consumer is interested only in one specific type of event, this consumer will of course need to process all types of events. So here we have a kind of dispatcher consumer that takes these two gray and yellow types of data and writes them to corresponding specialized topics from where you can plug other consumers that will have much less data to process. And that's exactly the purpose, the events classification. And as you can see, it acts a little bit like a proxy between the end consumers and the producers that put all kinds of events to the same storage. As a drawback, it can add extra latency because in an extra component you have the processing time, the reading time, the writing time, and yeah, that is not a silver bullet, but for me it's a great pattern if you want to avoid the overhead of reading the same data or filtering irrelevant data on the consumer's side. After that, we also have the message expiration, so how to inure to old events. And here the idea is to simply discard the events that are too old for processing. We can imagine that here we have our first record on the data source whose TTL, so time to live, was reached. Put differently, it expired, and now it's not available anymore for processing. So here there is one, I would say, challenge, because the consumers may miss the data not because of some quite huge age of the records, but maybe because they are too slow to process it. So for example, if you are supposing to process data in minutes and your consumers take multiple hours instead, the TTL will be reached in a lot of events, and yeah, that will be bad luck because you will lose plenty of records. And as an example of implementation, you can see that is implemented on the source, and in Apache Kafka you can define the topic compaction that will analyze the records, analyze the timestamps regarding the real time and the TTL configuration, and remove them, so compact these file segments on disk. And that's all for this lesson. There are 6 patterns. I think that these 6 are maybe the most popular ones that you can encounter in your data engineering adventure, at least in the beginning. And I hope also that when you saw them in high level architecture diagrams, you will be able to implement them much more easier with the code as soon as you get some practice. Thanks for watching, and see you in the next lesson.